Section 2.8, Part 2, Function Operations and Composition. In this part, we're going to focus on operations on functions as well as composition of functions. In this first example, we have a graph. Our blue function is a linear function, and our red one is a square root function. And we're going to find these four operations here at the top. So f plus g of 4, f minus g of negative 2, f times g of 1, and f divided by g of 0. For f plus g of 4, the first thing that we need to do is find f of 4 and g of 4. The way we do this is we find where x is 4, since 4 is what's in the parentheses here, and we look at where our blue and our red functions cross that. So the blue function crossed it up high, and the y part of that point was 9. Then we had the red function where we crossed that kind of lower, and the y part of that point was 2. Next, we're just going to add 9 and 2 together to get 11. For f minus g of negative 2, we need to start by finding f of negative 2 and g of negative 2, and then we'll subtract those answers. Well, look for negative 2 on the x-axis, and you're going to notice that function g doesn't even cross that vertical line. So technically, function g is undefined at negative 2. So we say for f minus g of negative 2, since g of negative 2 is undefined, our answer for this is also undefined. Next we have f times g of 1. We find f of 1 is 3 and g of 1 is 1, and then we take 3 times 1 and we get our final answer of 3. For f divided by g of 0, we need to find f of 0 and g of 0 first. Once we do that, we're going to divide them, so 1 divided by 0, and we notice that we have 0 in the denominator, so this answer is also just going to be undefined. Next, we're going to evaluate functions using a table. So in this table, my first column is my x values, my next column is function f, and then my third column is function g. We're going to start by finding f plus g of 4. So we need to find f of 4 and g of 4. F of 4, if you go to where x is 4 and you look at the f column, we get out 9. And for g of 4, if we go again to where x is 4 and we look at the g column, we get out 2. We're going to add 9 and 2 together and we get 11. Next, for f minus g of negative 2, notice that g is undefined when x is negative 2. So since it's undefined, f minus g of negative 2 is also undefined. For f times g of 1, we need to find f of 1 and g of 1. So go to where x is 1 in the first column, and then we see that f of 1 would be 3, and g of 1 would be 1. We're going to multiply those together and we get 3. F divided by g of 0, we're going to go to where x is 0 and then look over, we get 1 out for f of 0 and 0 out for g of 0. We can't have g in the denominator, so again we see that this is going to be undefined. Next, we're going to look at composition of functions. If f and g are functions, then the composite function or composition of g and f is defined by g composed with f of x. The domain of g composed with f is the set of all numbers x in the domain of f such that f of x is in the domain of g. First of all, I kind of want to draw your attention to this symbol. This is a new symbol with composition, And sometimes people confuse that with multiplication. It's not multiplication. That open circle means composition. A closed circle, so a dot, would be multiplication. Next, I want to tell you that we could either write the problem in this form or this form, but they mean the same thing. So composition is always about plugging one function into another. So for this first one, what this says is take function f and plug it into function g. So everywhere that we see an x in function g, we're going to plug function f into that. Same thing with the second one. It just means take function f and plug it into function g. So for example A here, I've written the composition statement two ways. They mean the same thing. So f composed with g just means to plug function g into function f, which is the same thing as what that one's saying. So what we're going to do is we're going to take function g and we're going to plug it in to function f. After we do that, we're going to distribute the two and combine like terms. For part B, we're kind of going backwards here. The way that these statements are written says we're going to take and plug function f into function g this time. When we do that, we'll notice that we have a binomial squared. You'll need to use either box method or FOIL here, and then combine like terms. The last example, example C, says f composed with g of 2. So on all of the examples on this page, this is the only one that has a number as opposed to an x. So what we're going to do is we're going to actually plug 2 into g, and then whatever we get from that, we're going to plug it into f. So notice how I draw these arrows. We're going to take and plug 2 into g, see what we get, and then plug that into f. I think these arrows would be very helpful to have in your notes. So g of 2, we get 0. So now we're looking for f of 0, and our final answer is 1. Anytime we have an x in the parentheses, like in examples A and B on this page, you should expect to have maybe an expression left over. So that's something with an x in it. But if we ever have a number in the parentheses, like in example C, then your final answer should be a single number.